All right, well, thank you for having me and thanks for being here. So I just want to go through a contractor's perspective of how and why we do sustainability. If you do have questions during the presentation, we can. Hold on. The right.
How should we?
Oh, this is not.
Okay. All right, so of course the sustainability approach, the three pieces of sustainability, the three legs, the social, the economic, and the environmental. And we're trying to take an approach where we get that centerpiece, where we get a sustainable approach, right? We care about each one equally and move forward in that way instead of in the past where, or even now, economic viability has really been the key leader for our approach. In order to do a sustainable approach, we've used the framework of the United Nations SDGs, which I'm sure most of you are familiar with. There's 17 of them, and I think they apply to geotechnical engineering and construction in many ways, and I'll go through that more in a bit. So as a contractor and a designer, we know that there's different ways to assess projects for their sustainability aspects. And so in America, three common ways are LEED, Living Futures, and Envision. And then there's lots of other ways, and I think some of those you use in Europe as well. But what I found is very few of our projects actually use these sustainability systems and metrics. So although it's great if you're on a project that has LEED and it kind of pushes us to do something differently, it doesn't really come up very often, not nearly as much as we'd like it to. So in that case, when we go to address the issues that sustainability is trying to fix and solve, the challenges, we can't really rely on those project-based systems because they aren't really most of our work. We have to take our own approach. So instead, we can use internal systems and we can be company focused and we can set our own goals. And that's what we've done at Keller. So with the framework of the UN SDGs, we've made ESG commitments. So many of you are familiar that environmental, social, and governance, ESG, is how sustainability is often reported and categorized. So we can make those commitments and targets and put them all together and line them up. So at Keller, we use a 4P approach: project, planet, people, and principles. And then we align those to the UN SDGs, you can see there. And then that feeds into our environmental, social, and governance reporting to allow us to be accountable for what we do. So on the environment, there's many things we could address when it comes to the environment and sustainability. But we at Keller are really focused initially on carbon. And we think that's a great place to start for a few reasons. So first, a changing climate affects what we have already built. So a lot of these examples are from, or all of them are from America, but I think you can hopefully think of some that are from your own countries. So for example, in the northwestern United States, so that's Oregon and Washington, we had a huge heat dome last summer, and it was so hot, it caused the existing infrastructure to fail. Roads buckled. You can see some of that structure there, the damage that was caused. So what the engineers had designed for, the climate they had designed that infrastructure, which is meant to last 50 or 100 years, that climate had changed. We have sea level rise. And at Keller, we're doing a lot of work for coastal resiliency to address sea level rise. We do a lot in New York City, around Manhattan. We also do it in Florida. But an interesting part of sea level rise is the associated groundwater level rise, causing overland erosion and things like slope instability. Also, for our buried infrastructure, you can think pipelines and tanks that we've already put in the ground. If the groundwater level rises, that can cause serious damage. And then in Texas, we had a very deep freeze that was unexpected, and it had severe consequences. People died, they couldn't get heat. And so this electrical system, the grid, that infrastructure we have put together, could not withstand the new climate and the new climate extreme weather events that are happening more frequently all the time. Changing climate also affects how we work. So we had big wildfires on the west coast of North America. Obviously, around those wildfires, the air quality was very, very bad. That smoke from the wildfires went all the way over to New York City, causing poor air quality in New York City. As geotechnical engineers and contractors, all from start to finish, we work outside and our people work outside. So if we have poor air quality, how are we going to do that? We have more work injuries related to heat. And it's not just extreme heat during the day. A big issue is rising temperatures at night. So when our workers are out during the day, if they go home and they don't have air conditioning, their bodies can't cool off at night to get reacclimated for the next day. So this is really concerning in our northern states where a lot of people don't have access to air conditioning. We also had Hurricane Ida that came through Louisiana, and that affected Keller directly in two ways. One, a site we were trying to get on in this area in Louisiana was flooded, and we couldn't get in there for a month. It delayed our project for a month. Another way was it shut down these chemical plants on the Louisiana coast, and they make PVC pipe, and that PVC pipe we put in our drilled shafts for gamma ray and CSL logging, and we couldn't get them. We couldn't get those pipes. So that actually affected how we work in two ways. Another thing is supply chains. So a professor at MIT saying climate change will disrupt supply chains more than COVID. We probably could say we have both of those things going on right now. But what's interesting is he also says the best way for a company to protect itself is to be proactive in reducing their own carbon footprint. And lastly, a changing climate affects the types of projects for the future and how we're going to build them. So out of the state of New York, we had a $600 million project with some of which was going to water infrastructure and resiliency. So trying to adapt to the changing climate. Then, of course, in America, we had the infrastructure package with $50 billion going towards resilience. And then in New York City, this is kind of new for us in America, they're preventing access to natural gas and heating oil, which are the ways we would typically heat a building. You can't use that in the city for new buildings. And so, of course, that lends itself to energy piles. And then lastly, we have concrete, steel, and aluminum responsible for a huge amount of emissions. So are we going to be allowed to continue to use those materials as we have in the past? Or are we going to have to adapt and change? So that's why we care. That's why we're focusing on carbon. It really directly impacts us and it directly impacts our workers. So how do we do it? The main way we look at carbon is through the wonderful carbon calculator. Thank you, EFFC and DFI for putting that together. It's a great tool. I put free originally second, but then I moved free back to first because I think that's a really great part of it. It's easy to use, it's updated. You guys all know how great it is. But what I really like is that it highlights the significant, what we call hotspots, significant contributors to CO2. So for example, if we're doing drilled shafts, we know that the materials are causing a lot of the issue with the carbon, the high impact heavy hitter. So we know if we're doing a drill shaft project, we need to look at our concrete mix design. That'll have a really big impact on what we do. Then if we do something like a stone column, we can see that the fuel that we're using also is impactful, almost as impactful as the material. So in that case, if we were able to switch to renewable diesel, then we can have a really large impact on the carbon footprint of that project. I want to give you a real quick case study on how we can use this tool. So here's an example in Florida for building foundations. So a standard high-rise residential building, 100 drilled shafts, 54-inch diameter, 83 feet deep. So we went through with value engineering, kind of adjusting the design, and our engineers recognized the deeper you went, you have more competent rock. Therefore, we could increase the strength of our concrete and decrease the diameter. So they knew that we were reducing the total amount of concrete we would be using. But if you're familiar with concrete mix design, you know that as you go to higher strength, you need more Portland cement, the biggest contributor to carbon in the mix design. So they said, Kimberly, are we actually reducing carbon? And so we did the carbon calculation, and sure enough, it was a 10% carbon savings, but also a schedule savings and also cost savings for our client. But then I pushed them. Now that we have this data, can you do more? For example, can you use limestone cement? This is kind of a new thing in America. I know you guys have been using it for a long time, those of you from Europe. So if you go to limestone cement, you can cut another 100 tons. If you say go to slag cement, a 25% blend, you can cut another 300 tons. And say you went all the way with slag, well, almost all the way, 75%, you can cut 500 more tons of carbon. And so I brought that to the engineers to say, that's not really that hard for you, right? That's working with, I mean, that's not fair, but you've already have your design. Work with the ready mix suppliers, work with the concrete company, what is available. And in the end, cutting over 1,000 tons of concrete is the same as carbon sequestered by 18,000 trees, grown for 10 years. And I also want to note 1,000 tons of CO2 saved on one project. Pretty big deal. But Keller does 7,000 projects a year. And of course, you can't save 1,000 on each, but maybe we could get that evened out. That's a really big deal. And I just present that to demonstrate it may feel like there's not much we can do as contractors or engineers, but that's actually quite impactful when you run the numbers. So should I stop there? You want me to stop there?
No,
Yeah, that's fine. Okay, so I'll stop there. We can.
Thank you very much. Very nice.
Well, I had a lot.
No problem. Very nice presentation. I noticed that you changed a lot of people use profit. You said, well, we are profitable anyway. Let's go for something more. Let's go for principles. Yeah. Very nice. Are there any questions for Kimberly about her presentation and Keller's initiatives on sustainability? Yeah.
Well, what is the main message that you would give to people that are not necessarily as involved in sustainability as Keller? What is the 5-second message that you would give to those people that you really get involved in sustainability?
Kimberly, before you answer, can you repeat that for people online?
Yes. The question is a main takeaway for people who aren't as involved in sustainability as Keller. I normally say, you can make a difference. When my friends come to me and say, can we really do anything? I'm going to show them these examples. You can make a difference. Download a free carbon calculator tool that we all have access to and run the numbers and see what can be done. And then get involved in your local sustainability committee and your professional organization. But we really can make a difference. It's not dire. I also have a slide on going from design, doing site investigation, how important a proper design investigation is so that you can do a really good design and you can optimize. And then that's actually what we expect when we go to the field to build, because the impacts across that value chain where you get to building and you're surprised, more concrete, more steel, that's when you make some changes that are negatively impactful. So all the way across from the very beginning of site selection to site investigation to design through construction, there's a lot of big impacts.
Well, thank you. Any other questions?
Only one comment from Germany. Great presentation. Congratulations. For us, it is the key is in 5 seconds. The biggest table what we have design. Every pile which we didn't need is good for the CO2 volume and for the planet. And there is only one table that is design. Not too far, drill faster, deeper, and less reinforcement, etc. No, the design is the biggest table in 5 seconds. Thank you very much for that.
Yeah, and indeed, that as Keller, in the basis, you are a contractor, but you take this piece of design with you and you convince the engineer that it should be done and made differently. That's what I like very much. And on the other hand, yeah, each ton of concrete, each turnover. But yeah, you want to exchange that for a better world. That's very good. Any other questions?
Thank you. Maybe it's a little mean question. One thing is to talk with the engineers to save a little percentage, maybe to replace Portland cement with slag, slag. But the other thing is you also talk with the controller, and at the end of the year you have to talk about the profit plan, and you're supposed to grow. And how do you deal with this? That issue. It's a system issue. It's a systemic issue, and nobody talks about it. We can save there and there. In every project we can save, but at the end we grow more than we actually save in every single project. How do we deal with this systemic problem?
Do they hear the question online? Can they hear the question?
Yep.
Okay. So the systemic issue of growth, right? It's a little deep. That's a great question. I mean, it's called sustainable development, right? It's not don't stop developing. Of course, it's not fair to other countries in the world, right, that haven't developed in the way that many of our countries have. Yeah.
I mean, if you believe the 3 Earth model, sorry, if you accept that currently the world needs 3 Earths to be sustainable, if you accept that, then there is no question in my mind that we have to have a new model that isn't dependent on growth. Correct. You know, the capitalist model wants growth. We've lived with that for many years, and we have to accept that growth should not be the basis of a business. A business should be able to be sustainable without constantly growing. Because why are you growing? You know, there is no real reason that growth is the primary driver. And we've got to accept that we're running out of space, materials, and time for the planet. And I'm not saying that we sack everybody. It's a completely different way of looking at things, saying, okay, if a company makes X% profit for the next 10 years, is that good? Is it bad? Is that acceptable? It doesn't need to be X plus 10 every year because the shareholders say that's what a proper company is. And I think that the more that the financiers who are deeply into ESG at the moment, because that's how they make most profit, they will force that, saying, well, hold on, growth for the sake of growth, is that really sustainable? Is that necessary? Hold on, yeah. You're very fit up for this.
That was a safety issue. Answer is very easy. We want to make our business and we want to make profit, but we have to do that. Yeah. But we must be changed the situation around. The demand from the client must be comes with rules that they have to have steps to reduce the carbon effect on the buildings, on the bridges, streets, whatever. And it is not a question from growing. That is completely wrong. We need to have to adapt our business with a third point, price, time. That was normal, the biggest points, big points for every small, the biggest project. And now the CO2 volume. And if we get the jobs over these 3 factors, the winner are design, the wins, and not the machines. And on site, we have 5% of the CO2 volume in our hands. You can drive faster and faster, but you reduce 5% to 4%. That is nothing. But in the material, you have 80% and steel and concrete and cement, cement in the concrete. And that is the biggest potential. If you can substitute, what is yeah, the cement. And do not dream about ash from the power stations, etc. That is only a breeze, it's nothing. But if you can change as globally, the volume of the cement with something else, what we didn't have in the moment, then we change our business in major. But business at first, otherwise you didn't have the money and you didn't get money from the banks for electric driven drilling rigs or whatever. You never get the money. You need the proper results that you are 10 years, 15 years in front of them.
But it's the company in other countries.
No, in Europe, I can only speak for Europe. The answer is taxonomy. Every country in Europe, from east to west, north to south, get money over the banks from the EU. Full stop. And that is the strongest input what we had. That is not clear in the moment. What are the effects? How long it takes, etc. But if the bank which gets the money for building, etc., spend money from bank to the client, he must be sent back the CO2 production. And that is hammer and stone in Brussels. And it will come up in the next 5 to 10 years. That is the demand. But also the public nations must start a campaign for the public projects to reduce this bigger project, tunnels, streets, etc. Also, if the public countries didn't do that, the way becomes longer than 2045. One final comment, Gerald?
I think to say that there should not be growth, I think fundamentally I have a problem with it for a couple of reasons. One of it is when you look at the overall population of the world that is growing, basically means that in order to make something sustainable for the whole world, there needs to be growth in various companies. That's number one. Number two, sustainability sounds great, but it is going to take investments. We need to do things differently. We need to do certain things differently, and it's going to cost money. And the only way you can get it to companies paid for it by companies, you need to get growth in those companies to make that happen. Otherwise, we'll keep going in the same course. If you don't grow, then there's no money here to change things around. Final comment. I think one of the things to sustainability you also need to think about, maybe it's because I'm a little bit older and have grandchildren, but what we have to do in this world is to make sure that our kids and our grandkids and then generations after may not live exactly the same way as we live right now, but are able to live a healthy and happy life in this world. If we are trying to ingrain that into people's minds and into concepts, you start to do things differently, do it more sustainable.
Thank you, Gerald. We have one final question or comment.
Thank you. Just very briefly, because I realise we've slightly gone off track from the contractor perspective here, but if you are interested in the kind of sustainable economics and decoupling economic growth from environmental impact, either kind of relative, so having less impact for the profit that we have, or absolute decoupling, where we actually have a negative, so a positive impact whilst continuing to grow. There's a lot of work from an organisation called CUSP, which is the Centre for Understanding Sustainable Prosperity, which is all about this inbuilt economics. Hopefully we can return a bit more to the contractor perspective for the next few talks, but yes, that's the academic reference if you're interested.
Thank you very much, Luke. Thank you very much, Kimberly. One thing I wanted to ask, I can do this because I have the mic. I see that, well, you presented that Keller has, in my opinion, more insight in their carbon footprint per technique than some companies have in their finances, period. And probably this is also something that well, could drive sustainability in the future, because you seem to know exactly where it's happening and where you can cut and where you can win. So thank you for showing us that this carbon calculator actually can help providing this insight. Well, I hand over to Chris.
Okay. Thanks, Kimberly. So next up is Alice Berry from Arup. And perhaps I'll do a slight plug here that many believe that EFFC is only contractors. That changed many years ago. We have associate members now, of which Arup are one of our very active. Kimberly's predecessor, a lady, has been on the Sustainability Working Group since it started, and Alice has taken over from her and is one of our most active members. So Alice, the floor is yours.
Thank you, Chris. It's really nice to speak directly after that discussion we've just had, particularly the comments about how design is key. And I'd say design is important, but I take it one step further up the food chain as well, that the client and the project is also important. We need to start thinking in the kind of mindset of investing some capital carbon in order to get a whole life carbon saving. So if that saves carbon, the users traveling along that piece of infrastructure, for example, and that's greater than the capital carbon invested, then it's an investment worth making. Building stuff just for the sake of it may not be the way to go. So a quick introduction to Arup. This is, of course, written by Arup. It reads quite corporately. So it says, dedicated to sustainable development, Arup is a collective of 16,000 designers, advisors, and experts working across 140 countries. Founded to be both humane and excellent, we collaborate with our clients and partners using imagination, technology, and rigor to shape a better world. So the rest of this talk is my interpretation of what that actually means. We're an engineering consultancy. We do work in the built environment, a lot of technical design work, but also work along project creation as well. We recently reissued our own internal strategy, and that is the header of the strategy. So that is the overarching pillar of information that we are, as a whole company, meant to work back towards. Sustainable development is everything. It's quite a bold statement. That is what the company is committed to working towards. That's the reason we're there. We are helped by the fact that we're a company that doesn't have shareholders. We're owned by the employees. And so we have a bit more autonomy maybe than some companies. Prior to making that commitment, we had already made a commitment to contribute meaningfully towards the Sustainable Development Goals. We do have our own net zero plan. So this is for the company itself. You can find it on the website and read all the details there, but I'm not going to concentrate on that in this presentation. And the reason I'm not going to is because of this next diagram, which we affectionately call the eyeball diagram. So just because of what it looks like. So the dark blue dot is our scope 1 and 2 emissions for the entire firm. So that's our electricity and heating the offices and things like that. The pale blue circle is our entire corporate emissions, so scope 1, 2, and 3. That includes our corporate travel, that includes our lunchtime sandwiches when we get them, and that includes our printer paper and all of those kind of things. But the peach coloured circle is the carbon impact estimated, and this is a study from 2017, of all of the projects worked on by one office, albeit the London office, which is our largest. And that's a whole order of magnitude larger. So the carbon that we influence is much more important, now that we already are sort of about our own corporate emissions, than what we do is, it's just essentially a lot of consultants working in some offices. So that's where we are focusing on trying to improve our sustainability. We made some public commitments. So during COP26, we committed to doing whole life cycle carbon assessments for all buildings. So embodied, capital, operational, and also user carbon where possible for all of our buildings projects from now on. And I assume we'll be making a similar commitment for infrastructure projects. So they're more tricky, which is why we can't say we're doing it for all of them yet. And we also committed to withdraw from fossil fuel projects. So as of April this year, we've not taken on any new commissions relating to the extraction, transport, or refinement of fossil fuels. And I'm quite proud of that. That's a bold commitment we've made. That's definitely putting planet before some potentially quite lucrative, profitable projects. We're also signatories to the Built Environment declarations. So as a company, we've publicly declared there is a climate emergency and a biodiversity emergency. And although the details of what we then commit to do as a result of that change, depending on which sector or which kind of region of the world has written their particular declaration, the content is pretty much the same. I recommend doing a Google search on Built Environment Declares if you haven't, and seeing whether your company could sign up if they aren't already. But what does that mean on a practical level on the projects that we do? So on all of our projects, when we're bidding for projects and when we commence our projects, we identify what the most relevant sustainable development goals are and what steps we can take to help them to become more sustainable. On many of our projects, we do carbon management in accordance with PAS 2080, which is a publicly available specification for carbon management in infrastructure. And it sets out a framework basically for assessing, looking at the whole life carbon impact of the project, so the capital carbon, plus the operational carbon, plus the user carbon, and then coming up with opportunities on that project to minimize and reduce that impact. And we do that actively on some projects and a little more casually on others, depending on the size of the project. We do our best to challenge the project scope. So rather than the client just saying, I want a bridge, design me a bridge, we do try and talk to the clients about why they need a bridge. Is it the right place for the bridge? Is the bridge future-proofed? Should it be a bridge? Could it be a tunnel? And all of those things. We do always try and have that conversation with the client. Some clients are more receptive than others, but we always give it a go. We always have a think about what the best outcomes should be and how to achieve those. On our projects, we set targets for carbon reduction, for example, for embodied carbon reduction. And of course, we do excellent design and optimize our design as best we can. And we do work with contractors to take on board their own particular techniques and specialisms that could have a better outcome as well. In terms of how we kind of determine the carbon impacts of these decisions that are being made, it depends on the project stage. At the very early stages, where for clients talking to us about developing, a bridge or a tunnel, then at that stage, or even, do I need something, or can I just put some smart controls on my motorway and therefore there'll be less congestion. It may be a qualitative kind of thing. Some of the options where you build nothing to get the same outcome, then there may be no need to do a carbon estimate. We've got libraries of carbon quantities for sort of typical elements, so a metre squared of facades, different types, cut and fill. Some of them country specific, some of them, obviously, if we're then working in a different country, we need to apply them with a pinch of salt. We do back of the envelope calculations, so essentially hand calculations or spreadsheet calculations to build up the carbon of options we're considering. Where there's a nice standardized method such as the EFFC DFI carbon calculator, we use those. When a project gets to the stage where there is a nice 3D BIM model, then we've got some interfaces there where we can apply carbon factors to the model, and then it will let us see where the hotspots are. And also we use commercial tools. So there's a plethora of ways to calculate the carbon depending on the level of detail that you have. And therefore, in my opinion, no excuse for not having a go at it. Why is it important? We've already touched on this. But we're used to making decisions as an industry based on cost and program, and then also thinking about buildability and risk and health and safety and welfare. And if carbon and sustainability are just a qualitative, it's a bit better, it's a bit worse for the environment, and there's not a number that goes with it, it's really hard to give it equal weighting or the right weighting compared to these other factors. Within the company, we have research and development funding available, and anyone in the company can apply for that. And quite a lot of that funding goes towards sustainability initiatives. We have these things called skills networks. We are a large company, and so they're a mechanism for sharing best practice and knowledge, and also forum for asking questions. So there's quite a lot of sharing that goes on. We've got technical ones, and there's also a sustainability specific one. And we're in the process of setting up a specific decarbonisation skills network as well. And we also attempt to harvest the data that we do have and learn from that. And then we also look beyond the company itself, you know, creating more sustainable projects or coming up with a cool way to reduce carbon can actually lead to a better profit for us as a consultancy, but we try not to keep it to ourselves. We do, you know, spread around the lessons that we've learned. We collaborate with other organisations. So for instance, we're working with the Ellen MacArthur Foundation on circular economy and the Rockefeller Foundation on city resilience. This guide over on the right was a guide that we've just written for the World Economic Forum on biodiversity in cities. And also, we're trying to influence projects at an earlier stage as well. So to help our clients to build the right projects that give the outcomes that they actually want. So this image down at the bottom is for the value toolkit, which we've been developing with the UK government, that will aim to help public procurement to take a better, wider view of value as a whole, rather than at the kind of current sort of, it's not quite cost-benefit analysis, it's sort of cost-benefit analysis plus with a few bits tacked on. So this is trying to take a broader view. So that's it from me.
Questions?
Thank you, very nice presentation. So, I'm curious to understand that the decision-making process, what you just, the circle you presented. In your experience or Arab's experience, do you see that authorities in the tender evaluation in big infra projects, they talk about risk, price, schedule, everything, buildability, but we still don't see carbon coming into the play. So how do you see that, we are already running a sort of time in this whole environment?
Yeah.
So, any comments on that?
Yeah, I think carbon could be given a much more prominent place. There is one example that I'm aware of from a company in England called Anglian Water, where they did an experiment, and I can't remember how long, but they procured on carbon, embodied carbon, rather than on price. And they did get big carbon reductions. I think it was around the 40% through innovations that came out from the supply chain. And they also had cost reductions. So because a lot of these things reduce material use and so on, which then also gave cost reductions. So there's definitely opportunity there. I would agree that at the moment, many clients are not asking for sustainability, or they are, but then they're also asking for so many things that everything gets very diluted, and it's hard to see, which one is going to win. But I think we still need to keep trying. We can't just give up and say, well, they're just not procuring it right, or they just asked for the wrong project. Never mind, I won't try and influence it.
But I think also that certainly in Europe, there is 600 billion euros allocated over the next 5 years, and it's all related to the Green Deal. And if you don't look at the carbon elements and reduce, then the finance will not be given. It's quite complex, and obviously for the Americans, it's not relevant, and probably not relevant in the UK, if I'm regrettably saying, but certainly in Europe, that taxonomy and Green Deal is alive and well and due to hit everybody in 2023. So it is a big deal. Whatever your views on sustainability, if you don't fall into line, you won't get work, because assuming that many of you are subcontractors to main contractors, the main contractors won't want to know if you're not giving them scope 1 and 2, and you've got a good record. They'll just say, I'm sorry, we're going over there. I think also, if I can make the point, and this, I sometimes get asked as a consultant to look at diaphragm wall cages and things because of the work I did on the Tremie guide. And
It was actually an Arab job, but I won't blame you. Hear me out before. I've never seen so much steel in a shaft in all my life. And I said, this is ridiculous. Who the hell designed this? And Arab. I said, oh, I better be careful what I say then. But it was actually a long history that 4 years ago, somebody had said, we want a shaft with no nothing. We just want to cut holes in it and it to be stable. And the design case was ludicrous. So Arab designed all this steel that could actually take it. And then they changed the method. And so what they were building was a normal shaft, but with reinforcement for an extremely difficult design case, yeah? And why? Because it was a government job and it takes 15 months to get anything changed. You have a category 3 checker and it goes through all this process. And to say, oh, we're going to change it, they couldn't do. So we're putting things in the ground that are grossly over-designed because of bureaucracy. And the whole system needs to change to get priority, to prioritize. We want to reduce the steel. Yeah.
Yeah. I think there should be a challenge to what's there, but I think that's also a lesson learned for Arab, that if we had perhaps challenged at the start what the constraints that we were given, then maybe that design wouldn't have got designed. I think we all have a past history. We're engineers and we love to find out what the constraints are and then come up with something really clever that fits the constraints. And we need to change that mindset a bit and ask if the constraints are the right ones to start off with. And then, once they are the right ones, design and build something to fit that.
There's an upcoming second effect, which is very useful. You have on the one hand side, you have the taxonomy. How expensive is money from the European Bank, only for Europe, excluding the British banks. And on the other hand, you have penalties you pay for CO2. So if you have a lot of cement in your building, in your bridge, etc., there must be an agreement with the publics and the politicians that they want to have a bridge with concrete. Otherwise, you have a wooden ones, very small. So, on this both hands, there's a strong demand. And the companies at first are the winners, and not companies who wait 10 years. Which are unclear, but this both effects are very strong. And they will coming up. There's no other.
Yeah.
Kimberly. Sorry, did you have a question? Yeah.
Yes.
Well, over to you and then Kimberly. Ladies first.
Thank you for your presentation. Very interesting. We're in the same working group within the EFFC, but another thing is for your clients, you can influence the price. So it's an earning model, and that's I relate to the discussion with the former speaker. It's an earning model also if you redesign it to green.
Correct.
Lose from the political issues and lose from whether you have to do it or not. So it's also an economical drive.
I agree, it's an economical drive. The earlier on you make a change, normally the more likely it is to save money as well as carbon. If it's retrofitted on later, it may cost. So there's a nice carbon reduction hierarchy. There's various ones around, but they all say more or less the same thing. And so looking first, do you need to build the thing in the first place? And if you do, can you build less of it? That tends to save money. If later on you come on and you retrofit some extra fancy material, which is a bit lower carbon, that's probably going to potentially going to cost money. And that's also the thing that's easiest to snip off later when there's value engineering exercise. So if you can bake in these better decisions earlier on in the process, then it's generally a good thing to do.
Kimberly.
A question on when your clients come and they're interested in a life cycle assessment, do you also do a life cycle cost analysis? And do you run like multiple scenarios?
We can do, yes, it depends. So we have people who do that kind of thing all the time. Sometimes, often in the UK, our clients prefer to have their cost consultancy through a different consultancy. But it's still interesting to see how those things tie in. Yeah.
Any more? Last one then, Luke, if we may, because we need to stay vaguely on track.
Watch my feed. Just very quickly, I realise we've focused a lot on so far, but I noticed earlier you said about the Element Health Foundation and circular economy type things. Just curious about some of your other sustainability priorities and how you're making those into your projects. What do you tend to prioritise? What do clients tend to prioritise?
I think at the moment there is a lot of focus on carbon, and that does have then the knock-on effects to other things like, you know, biodiversity and so on. Circularity is harder when to think about when we're designing things for a very long design life. It's much easier when we get to the other end of Arup's kind of consultancy work. If we're thinking about facade systems and things like that, then obviously designing for reuse, replacement, repairability becomes a lot more kind of obvious. We also do a lot of work in resilience and looking at hazards and things like that. It's big and complex, but we're engineers, we like complexity.
Okay, right. Thank you very much, Alice. That's very good. We'll move on.
Thank you, Alice. Our next speaker will be Dick de Wever from the Netherlands, from Rijkswaterstaat. Rijkswaterstaat is part of the Dutch Ministry for Infrastructure and Water Management. And Rijkswaterstaat is responsible for design, management, construction and maintenance of our Dutch infrastructure.
That's right. Patrick, thank you very much for having me here and for the introduction. Can everybody see me? Hmm? So I'm very glad that I was invited to talk a little bit with you about the transition to sustainability, and the focus of my talk is on non-fossil machinery, including the logistic parts. And I'm very much aware of the fact that in the foundation industry, the machinery may contribute for a fairly small part to the sustainability goals. But nevertheless, this may be a very interesting example of an approach from a government point of view of how we try to achieve this transition from a fossil-driven sector to a sector that is mainly focused on more sustainable machinery and logistics. The picture at the left-hand side of this sheet actually sums it up quite well. This is the road, sort of scheme of the roadmap that we have developed towards a zero-emission construction site, with 2030 as the milestone year. So we've given ourselves approximately 10 years to achieve these goals, and that is because our government has set the goals for carbon reduction and a few other goals in the year 2030 already. I'll come to that later. On the left-hand side, down in the picture, you see the policy objectives, and on the roadmap, our roadmap consists of 4 tracks. The policy and strategy track, of course. One of the big tracks is the technical developments. We have to pay for these developments. There is a cost calculation included, which is the finance track. And the central element in our approach is the procurement strategy that we are developing at the moment. And that will be rolled out in the next couple of years. That is the procurement track. Our sustainability policy objectives of the Netherlands government are much broader than the 4 that I've summed up here, but these are the drivers for this transition, and I'll fly over them very quickly. It's climate, mitigation of climate change, the conservation of biodiversity, which is a specific Dutch problem at the moment because we have large nitrogen emissions all over the country, and we have to deal with that. So that's one of the major factors which has given an impetus to this transition. The air quality improvement objective, because we're a densely populated country with large health problems in the densely populated cities. And the fourth objective is the occupational health related, which is aiming at the reduction of carcinogenic diesel exhaust emissions, because that is a major factor in the health problems with the workers on site. We have been looking, once the climate agreement in the Netherlands had been established, we've been looking at the parts of the work that is carried out by our Ministry of Infrastructure and Water Management and its associated agencies, which parts of the jobs could provide for the biggest carbon reduction. And there have been 4 transition pathways defined for the Rijkswaterstaat organization, which I'm involved in. And this is the road pavement, as we call it, the kunstwerken, the artificial objects, bridges, tunnels, sluices, etc. The shore maintenance and dredging, which is mainly on digging and groundwork, and the machinery involved in road works, dike works, and we cooperate with our railway agency, so the railway works are included as well. The scope of this, the latter transition pathway, is on-site construction equipment, the transportation of material and vehicles, and the optimization of this material and ground transport, and including the design and the logistics part. The technical measures that we envisage to achieve the objectives are, in the end, zero emission machinery through electrification, which is our main goal that we are looking at now. And there are actually three main pathways to achieve electrification. You can use power grid supply, so machines that are driven by a power grid, a power plug. The more mobile machines may want to use battery electric driving facilities. And another one is the fuel cell, which will make use of hydrogen, which may be a better solution if you need a large power or if you have faraway locations which are not so easy to supply with batteries, or where there's no power grid present. And for the short term, we encourage the use of clean machinery and clean energy, including improved combustion technology, non-fossil combustion engines, and also biofuels, although there are some limiting factors which make biofuels not such an easy solution for the whole sector. As I already said, our main approach is to achieve these goals as a government agency, as a client, because we're not the contractor, we're the client, we are putting contracts on the market. And procurement is our biggest instrument. And our procurement strategy is fairly simple. We use a combination of requirements, so minimum levels that should be applied, combined with award criteria, which is a method to stimulate contractors to do more than the requirements require, and we pay for those additional ambitions, and in a financial way, or by giving them an extra probability of winning the contract. On the contractor and project level, we distinguish the average contractors, or the average projects that have to fulfill the basic level of requirements, and there are front runners which can apply for contracts with an increased level of ambition, and also the award criteria are a little different for those two categories of contractors and projects. The key points that we have to deal with in the next few years are the scaling up of the production capacity of zero emission equipment, because these are all very nice ambitions, of course, but the equipment has to be on the market. We already are confronted with contractors who say, well, we want to apply these zero emission machinery, but we just cannot buy it because the manufacturers are not able to deliver. So that's a major factor that should be solved. Another one is the mobile charging facilities or the power grid reinforcement. The zero emission machinery has to be charged, of course. Without current, there's no charging, and they won't be able to operate. We have to have more insight in the cost breakdown of this equipment to get a firmer underpinning of the procurement strategy. And we also realize that, as you see in the picture here on the lower right corner, you remember the finance track of the roadmap. We have to have more insight in the costs, but also in how can we pay for the additional costs that contractors have to make in the first years, because we're convinced that in the end the costs will go down because the investments will go down, and using zero emission equipment in the end is cheaper than diesel equipment, because your energy costs will be lower and your maintenance costs will be lower. So that's the long-term perspective. But to get there, we have to pass a few thresholds, and that may require subsidies and additional project funding, which we provide for from the government. I have some examples of where this is already taking place at the moment. A road construction project in the neighborhood of Rotterdam, where there are excavators, an asphalt cutter, a complete electrical asphalt set, a sweeping truck, some cranes and telehandlers. I would have loved to show you here also the foundation equipment in an electrical way that should be part of the project, but the project had already advanced in such a way that it was no longer necessary here. So that we save for another one. And you see in the CO2, the carbon reduction is about 1.5 kilotons in this project alone. And we pay for this altogether 4.5 million euros additional costs to help the contractors to make this transition. There's another project on the River Rhine where excavators are being deployed, a shovel and 3 dumper trucks, and a crane ship that is still to be developed. Also with substantial emission reduction. And with, of course, extra costs which are provided for. And the last one I want to show you is a maintenance contract in the eastern part of the country, where the contractor has very proudly presented its first full electric asphalt set, which is deployed right as we speak these weeks, which costs in this small project 120,000 euros additionally. And the emission reduction is rather modest, but still 93 tons per year when applying this type of machine is significant, I think. So these are some quite nice examples of what is going on in the Netherlands at the moment already. Well, I had the instruction to be brief to keep some time for questions. So.
Thank you very much, Dick, for giving us a client's perspective and confirming that there is at least one client for us as contractors that let go of the price.
We're happy to receive
criterion. Yeah. Oh, but looks like a bright future. Any questions for Dick? I see one there.
Thank you, Abla, from Keller. One question regarding our, currently we have big rigs, really big ones, and we are forced to do that with electric ones, of course. Are you planning a way of providing energy for such rigs? Because this is one of the biggest problems when you can to charge our batteries, of course, during our work.
Yes. I have had a similar question of a company in the Netherlands, and they are trying to develop electrical rigs for application in the Netherlands, and they're faced with the same problem. And as I said already, batteries may not be the future for equipment which requires high power. So if you need a lot of kilowatts and especially high peak powers, then hydrogen may be the better solution in this case. So in that case, this might be a part of the sector which is better off with a hydrogen-driven equipment. Yeah. Okay. Thank you.
Following question also. We can work with electric rigs, but you don't have the green energy.
Yes, that is a higher level question, of course. At the moment, we're doing our calculations with the current electricity mix in the Netherlands, which is partly sustainable, but for the bigger part, it is still fossil. And we urge our government to increase the contribution of sustainable energy in the electricity mix, of course. And that's the only way to go if you want to be sustainable over the whole.
Yeah, I read in a German newspaper that Google take over all wind turbines in Netherlands. Is that true?
Yes.
So where who's green energy in Netherlands?
Yeah.
Russian gas or?
Well, there are lots of programs at the moment in the Netherlands where to add wind turbines. Especially on the North Sea. Yeah, there's a lot of wind at sea being developed at the moment. Yeah.
Do we have a question there? No, it's sorted. All right then, higher up even.
High level question. Yeah.
Yes. Thank you. Very nice presentation. Yeah, we are here, let's say, represented from the Ceecom Group involvement, and maybe not a question, but in addition to your presentation, that okay, we are as we speak building a big electric-driven rig for one of the customers who was just shown here on the presentation, and also electrical driven power packs to drive the vibratory hammers, and yeah, with combined solutions, so with grid supply, but they can also run on a battery independently from the grid. So I thought that might be a good addition to your presentation.
Thank you. That's interesting to hear.
If there are any questions, you can talk to us downstairs.
Yeah.
Thank you.
Okay.
Alice has a question. Chris, it's not a tease you, but.
What's your future? It's a fitness program.
Here's my temple.
I was wondering if, as part of your study, you'd also looked into the carbon payback period for creating these new rigs. Obviously, there's still a lot of emissions in use, but how long does it take to pay back manufacturing it?
Well, we made a payback calculation for the whole sector, and as I already said, the long-term perspective is that things get cheaper if you apply this type of machinery, and that will be the point where you reach that level would be around 2030, approximately. For some machinery, it will be earlier for the smaller machines, and for the bigger machines, it will take some more time. It may be more like 2035 or even 2040.
And in terms of the actual machinery itself, so you commission a new asphalt set, which and it saves 93 tons a year in operation, but how much carbon goes into building it? Roughly.
That's a very unfair question.
Yeah.
I don't need a precise number. I was wondering if that had been included in this study.
Yeah, well, certainly, yes. We do an environmental cost calculation, which is the basis of our procurement procedure, as I indicated in one of the sheets. And this would typically include, I think, 10 or 15 parameters, including carbon. And it's all based on life cycle assessments of the machinery and the energy that goes in and the other materials that go in. And so, well, we have a very comprehensive approach, I think.
Yeah. Next. I see our next speaker standing up, and I see no more questions. So I want to thank you once more, Dick, for giving us this insight. Speaker is Andreas Ziegler from Bauer Maschinen, and he is actually going to tell us more about the feasibility of electric rigs. Andreas, the floor is yours. If you want the mic,
yes,
you can have it, but it's also there.
Okay, I think I can speak loud enough. Maybe before I start my presentation, my personal calculations have shown that it pays off somewhere between 1,000 and 5,000 operating hours. So clearly before a typical machine life or end of machine life. To answer your question, I am between the coffee break and you. So the equipment manufacturer's perspective on sustainability is the subject of this short talk. I'm Director for Systems Engineering within Bauer Maschinen. I'm with the company for 11 years now. And of course, we also had a look to the sustainability development goals and developed our strategy in-house. I would like to show you 4 areas, for topics. And of course, the main topic will be on product and procedure. But before we go into this, maybe focus on employees and social, and so to say, the Bauer company, Bauer as a company is sustaining for more than 2 centuries now. And the main reason is because it's adapting to the context, to the environment, and to the business. It started as a coppersmith workshop more than 2 centuries ago, then came into water well drilling, into special foundation, and for several decades, we are now also equipment manufacturer, and in our resources segment, we are dealing with everything that is in the ground and is environment. Also, on employees and social, we are a very international company with more than 11,000 employees in several countries worldwide. And our colleagues, they are out of more than 80 nations. So to say that diversity is for us just as natural as the ground we are working in. We work together with many nations and colleagues all over the world day to day. Focus on supply chain and production. We have done in the recent years some internal studies. What is the carbon footprint of a drilling rig, of a typical drilling rig? And the message here is quite clear. It's more than 90% is the raw material. And so when you look at a drilling rig like this, you simply can ask the question, where is the steel from and what is the basis of the steel? And this also gives clear approaches how to reduce it, to use recycled steel and to avoid steel and so on. So this message, I think, is quite clear on this slide. But also in supply chain and production, there is potential for us as a company to reduce emissions and footprints. We are in the middle of a very large internal project called supply chain management, where we really focus on every production step of our rigs. And of course, one of the main goals is to avoid any losses, to reduce the cost. And for us, most important maybe is the make to order, that also the production and delivery is within a very short time, so that we can react on the demands of projects very fast. Let me now come to the main topic of the presentation, focus on product and its operation. We have done a quite large research project, which was funded by the German ministry back in 2012, where we already analyzed the influence of several parameters on fuel consumption of the rigs. And for that, we also did test drilling at our plant. And just to show you that influence, which was, by the way, already in your presentation with a carbon calculator, the influence of the procedure. And this slide shows our results from 2012. We simply did drilling, 880 millimeter diameter and 20 meter depth. And you see the liters of diesel for that same result. The result in the end was absolutely the same, one hole. And by doing this with a Kelly method, we measured 60 liters of diesel per hole. Doing it with CFA or with FTP, we came down to around about 12 liters for those 20 meter of depth. And you see the influence is a factor of 4. And so from our point of view, after talking about concrete and cement and steel, choosing the right procedure, the right method is the biggest lever. And what does that mean for the machine manufacturer, for the equipment producer? Well, we need to supply flexible products. And this slide shows the applications which are possible with a duty cycle crane out of our product portfolio. And you see that more than 10 different procedures, more than 10 different special foundation methods are possible with one single equipment. So the contractors are able to select the best way to do the work, and this flexibility is quite important. Of course, also the machine efficiency has an influence, and it was one of the main results of that research project back in 2014 and 15 that we came out with our so-called energy efficiency package. And the first diploma thesis of one of my employees in 2009, it was just a rough calculation, said that these measures will reduce the fuel consumption by 10 to 30%, depending on the application in the end. Now, 10 years later, we can look at the telematics data to the fuel consumption of the rig fleet, and can create a graph like this, where you see the rig size, or you could also say the power class to the right, and the average fuel consumption, and you see the wide area of fuel consumption per hour. It depends pretty much on the application in the end. But on average, we can prove now with more than 500 machines in operation that these machines on an average will need more than 20% less fuel. And this sums up to 3 million liters of diesel averaging or saying more than 11,000 tons of CO2 equivalent. So there is an impact. This graph here, by the way, is also for me very important when we talk about electrification, because here we have these numbers we have just talked about. We have the size and the power which is needed, and the fuel consumption, which is the energy that is needed. And we separated, after a lot of analysis, these areas into two application ranges. And we, from our point of view, and this will be one of my messages tomorrow, one of my statements, that we say low performance applications. And in special foundation, this is Kelly drilling, mainly Kelly drilling, up to a performance of 250 kilowatt, a rig size of 25, 30 maybe. Here we see a clear application for battery powered rigs. These limits are rising and technology is developing, but the main field of special foundation is still standard and high performance application, the single pass applications, the diaphragm wall operation, and so on. And there it's simply the question of investing in a very expensive battery and the supply, the charging situations where we say this is an area where a cable powered operation makes pretty much sense. The rigs are not really more expensive, and you see one example of an electric rig of a 33 class in operation here on this picture. My last slide, just some more examples on electrification. Clen, as one of our associated companies, is producing several small power application rigs for small diameter drilling up to 200 kilowatt. And of course, there it makes pretty much sense to do this in an electrified way. But also when it comes to applications where you are on the line anyway, as you have a slurry line or a cement or grouting line, then maybe it's not that big effort also to have a power line. And therefore for diaphragm wall operation, as well as for mixing and single pass operation, we see a lot of potential for electrified rigs. Thank you very much for your attention and ready for your questions or the coffee.
Andreas, well, good to hear that in assembling and designing an electric rig, you also look after your own processes and design that it's really sustainable. Any questions for Andreas?
A question on, in an urban environment, plugging some of your really powerful big rigs into the grid, is that a problem for the grid? How do you know that, or how would you find that out?
At least in Europe, and as far as I know, in most of the regions worldwide, there is somehow a red line at a power of 88 kilowatt. The reason is availability of standard components. For 125 ampere, you get standard plugs, you get a lot of technology, standard industrial technology. And even at small job sites, that's simply typical that you have this CEE 125 ampere plug. So as soon as you are below that, that line, everything is totally easy, I would say. But as soon as you come above, the hurdles are bigger and bigger, and we know that for many regions it takes months to get this connection to the job site. And this is also the reason why we say, okay, some 88 kilowatt equals somewhere around to a fuel consumption of 20 or 16 liters per hour, where we say, okay, everything that is below is quite easy to solve, but everything that is above is hard to do.
A technical question. Your motor heads, which are driven with hydraulic energy in the pump, are you prepared to change that to electric, piece of electric motors? That you didn't have some losses between electrics to hydraulics and then to the motor head or something?
Of course. The main question is not the technology question to do this. I mean, engineers are prepared to do, and the efficiency advantage is clear. However, it's quite small. When we talk about fuel consumption or power consumption, in the end, we talk about some single-digit efficiency gains. But let me jump back to that slide on the applications. This is the main reason why we haven't done it so intensive in the past. As soon as you exchange in a rig like this, the diesel motor by an electric motor, you are still free for every application. Every equipment that you have is possible to be used. And this is the main reason why we only see some first steps into full electrification in the market and also at competitors. And
my question was linked to the project in Münster. That was an EG.
Okay, in this case, it is an electric hydraulic powered rig. So there is one central big electric motor driving the system, but all the consumers, all the drives in the machine are still hydraulic. Meaning that on this rig, you could also attach a diaphragm wall cutter, for example, by simply exchanging the equipment.
If you have some energy in this field.
Yes, yes.
It's in the city, but outside the city, Germany didn't have the infrastructure.
Yeah.
Okay.
Thank you for your nice presentation. Maybe as an addition, as a colleague company, we talked about, let's say, efficiency. Let's say I just mentioned to the previous presenter that, okay, we are building currently this electric hydraulic. In that sense, I agree with you that our customer choose because of the multifunctional applications that next to drilling, they also want to use it for vibrating or impact, hydraulic impact hammer. But yeah, okay, I disagree a little bit with you on the point of efficiency, you know, because in our machines, for example, 800 liters per minute go to the rotary head. So when we see there's still a big possibility to increase the efficiency. So therefore, we are also able to deliver an electric rotary head, but that is just as a small addition to your presentation.
Right. Any other questions?
We have some coffee.
Good question, Chris.
Well, I should say that I was offered €100 for my warmest hat for our friends in Ceecom. So.
And
another 100 euros for mentioning the name, Chris. All right. Well, thank you very much, then, Andreas.
You're welcome.
Take it away.
Yes. So, hello, everybody. Hans Weber, ArcelorMittal. You might have heard of our company. We are not less than, we used to be the biggest steel producer in the world. We have been overtaken last year by a Chinese consortium, which is now slightly bigger than we are. But well, ArcelorMittal has its legal head or the legal corporate in Luxembourg. So we are a European producer, but we have more than 60 production facilities all around the world, which means that we are following, or we have to follow all the rules in the different regions of the world. And so our global strategy for decarbonization of steel is a bit more difficult than just looking at our European operations, because we also have to see what's going on in Africa. We have to see what's going on in South America, in Canada, wherever we have production facilities. It's our aim to make the steel more environmentally friendly. By 2030 and 2050, the global strategy of politicians and the industry is to be more or less carbon neutral in all the production. This is especially severe for the materials that we are working with, means steel and concrete. I'm talking today of the steel, but concrete and cement have even a higher output on CO2 than what we produce today when we make steel. We have a plan which is backed up by our upper management. So we are definitely investing a lot of money, especially for the moment here in Germany. You might have heard it. We have in Hamburg a production plant where we are making DRI iron, direct reduced iron. Steel making means we use a lot of gas, natural gas, and we produce quite a lot of CO2. And if we substitute the gas by oxygen, then we can reduce that significantly. I will show you some numbers on that a little bit later. But we are investing quite a lot of money. Looking at the past, we already published in 2019 a first group climate action report. Group means worldwide. Then we had in May 2020 a special European climate action report. That's why I mentioned in the beginning. We have to look at more than one market, which makes it really difficult. And in July 2022, we have given out the second group climate report, where we already announced that we are trying to reduce on a global scale our CO2 emissions by 25% in 2030. And when we look only on our European production sites, we even try to go to 35%, which is quite an effort. We will have the first carbon neutral plant in Sestao, hopefully by 2025. By using different measures and means of production, we can achieve this. We see that the customers are more and more demanding CO2 reduced products. So we have launched our X-Carb brand. So we will produce in Europe steel under the X-Carb, which means low or in the end zero carbon emission steel. This doesn't come for free. We are looking for the moment at a 10 billion euro investment to achieve that only in Europe. Part of that will be financed also by the European Union and the German government. As I said, we have some special plants here in Germany, which will be changed in a way that we can really produce our iron in an absolute CO2-free way. We can reduce direct emissions that come out of the different furnaces, plus the secondary emissions. And in a third step, we will also go to storage facilities or storage chemical deposits where we can put the CO2 store it into a CO2 battery. But this is future 2050. There's still a lot to go. When we heard about the Rotterdam construction site, I was a bit shocked. Remember the numbers? For 4.5 million euros, there was a reduction of 1,500 tons of CO2 on this job site. This is about what we produce in a day. And if we have to put that into numbers, no one would be able to pay. So we see the road to zero carbon emissions is a long and expensive one. We distinguish into different production possibilities. The ones you all know is the blast furnace, which has the most of CO2 emissions. We see here between 2.2 and 2.8 tons of CO2 per ton steel produced. That's quite a lot. And we can reduce it by going to an electric arc furnace. We call it EAF. There we are already between 0.6 tons CO2 per ton steel produced and 0.8. And we can further reduce that if we use green energy. So when we take the electricity out of wind parks, out of solar energy parks, then we can go down as low as 0.3 tons CO2 per ton steel produced. So we see here a significant reduction is possible. The future steelmaking in Europe will be no longer through the blast furnace, but it will be electric arc furnace. That has a lot of positive effects. We can use what we do today already. We use scrap. So everything that we throw away that's made of steel ends up in our furnace. We melt it down, we turn it into beams, into sheet piles in Luxembourg. The material is reusable again and again and again. And once we have the primary iron ore melted into steel and we made a car out of it or a chair, whatever, this can be reused. So we are not wasting any primary resources anymore. So recycling is one of the major steps that we will go. The problem is we are not only doing beams and sheet piles and rebars, we are also doing car bodies, very thin profiles. And for those who know a little bit about steelmaking, this is not possible with recycled steel. You cannot roll it as an EAF recycled steel. You cannot roll to 0.2 millimeters. There you still need iron ore. And we will stop the blast furnace route in some years. And we will then use iron ore that has been already treated, not with natural gas, but with oxygen. And we will melt that down in an electric arc furnace. And by doing this, we can achieve this very, very low CO2 emission level. So this is definitely something that will change the industry because we literally have to change our production facilities. We have here close to Berlin in Eisenhüttenstadt, one of the biggest steel works in Europe. And this will be completely rebuilt into a CO2 neutral way. The next problem is, if we do that here in Europe, this will come with a cost, as I said already. So what do our customers usually do? They are looking for the cheapest way to go. Which would then be the cheapest way? Well, import steel from, I don't know, Malaysia, China, wherever you get it from, where these duties that we have to put on our steel prices are not to be paid. So this would lead directly into our bankruptcy and into the industrialization of Europe, because no one would be able to afford. So this is the point where politics come into play. And next week there will be a European political meeting to discuss about CO2 border taxes. So to protect the European industry on the way to being green, we have to put taxes on everything that's imported, which is produced under different ways of production. So this really has to be seen on a global scale. If we go to CO2 zero, CO2 neutral, we pay a lot. As we just heard, 4.5 million for 1,500 tons. That's a really interesting number. And others don't, because, well, China doesn't care. Maybe they do care, but it's very, very important that on a global scale, we are aligned. And I guess we are, or everybody knows the severity, and I think we will go that way, 2030, 2050 and beyond. I will quickly go to some of the X-Carb data, especially for the sheet piles, because we are here at the DFI Institute. So foundation is our business. The sheet piles, as I said, are produced in Luxembourg, 100% out of recycled scrap. For us, this is okay because we start with a thickness of 6 to 7 millimeters. So we are just perfect with the recycled steel that we have. In addition, we can use green energy, and by doing that, combining that, we can give you a product under the label of Eco Sheet Pile Plus, which is certified a green steel product. The certification process is also right now going on because we need third-party certificators to do so. As the road just started, there will be more to come, but we are definitely taking all necessary steps. For you as end customer or as designer or also as end user, it's very important that for our construction products, we have environmental product declarations. We were the first in the steel industry to give those out, and they are really based on our internal data. That's very important. The EPDs we have today are really fact-based on our production units. Sometimes you get EPDs which take some global numbers. Someone makes a stamp on it and you have your EPD. That's not the case with us. We have really, we were digging deep into our production facilities, and the numbers that we have are absolutely, or not absolutely, but they are accurate. Very important. We already have developed, not developed, but we have delivered a lot of eco sheet pile projects, especially, I have to mention here the Nordic countries, Sweden, Denmark, Norway. They are way advanced when it comes on the decarbonization issue already in the design stage. There the contractor gets points, positive points, when material is used which is carbon neutral. Switzerland will also go into this direction. So we will definitely see in the future, let's say in 5 to 10 years, much more steel construction. Concrete will have a problem because of the cement that's in the concrete and the large amount of CO2, which is inevitable. And steel is much more beneficial because it will last forever. We don't need to mine. We just need to take out the chairs when we don't need them anymore, throw them into the furnace and turn them into something new again. Even the slags that is produced, as the remains of the steel making, will be reduced for road construction, for example. So there is zero waste, very, very important. We have quite a huge range of sheet piles that we normally, let's say 30 to 40% of our sheet piles go into port projects. The piles are driven once and they stay there for the next 30 to 50 years. When the port is no longer in use, what can you do? Well, you just pull the sheet piles out again if they are in good shape. And you can either use the piles itself again, or you can bring them back to us and we melt them again and turn them into something new. So the point is reduce, which we did already on the last 50 years. Today, you need between 30 and 50% less steel for a structure than you would need in the 1980s, for example. We can do the reuse. You can use the same sheet pile over and over again. 5 to 10 times is easy to do. And we can recycle. So the steel will always stay with you in the construction business, either as the material you have or turned into new material, but it will not be lost. We are aiming at around 370 kilograms CO2 per ton steel produced. That's with our Eco Sheet Pile Plus EPD achievable. When you go a bit deeper into the life cycle analysis, you will find that it's very difficult because a lot of countries have different rules. So it's always important. The time, okay. Also it's important to see which phase of projects are inside your CO2 calculation. That would be another hour of presentation here to go into that detail. We have, as I said, the tables with the values that you need as a designer to do the calculations. It's all peer-reviewed and available on our website for being used. We also have specific case studies for port structures and for underground car parks that you can use as reference if you want to do your own CO2 calculation for a specific project.
Thank you very much, Ernst. My apologies for cutting you short.
No problem.
However, very interesting. Only thing, you have wooden chairs. And it was not for firing up the furnace, I believe.
Wooden chairs have a lot of energy in it. We throw them in the furnace also. That's not a problem. At 1,600 degrees, everything burns and gives nice slags.
You have an answer to everything. Any questions for Ernst? Alice?
Thank you. I particularly like your slide about the potential reuse for sheet piles and the fact that you have options for renting and so on. But can you talk a bit more about the availability of scrap steel? You know, if everyone decided they had enough money to pay for your X-Carve product, do you have enough scrap in the world?
Yeah. So the main plant for the sheet piles is in Luxembourg. And we are lucky that in the area, let's say 300 kilometers around the mill, we definitely have enough industrial facilities that constantly produce scrap, and only once in a while it's necessary to go on the world market and really buy something on a bigger basis. But normally, actually, we don't have a big shortage in scrap supply. It's really enough at the moment around Luxembourg. Where we, for the moment, have a problem is in the Eastern world, because we have in Ukraine a huge mining operation which is not fully working at the moment. This is giving us troubles. Also iron ore, supply for the moment is not as good as we want to have it, but the scrap for the moment, we get it. Prices are high, but it's not that there is a big shortage. Also our production is absolutely guaranteed and ongoing.
Any other questions? I think we're already on. Ah, Kimberly.
We left it there.
What about for the recycled scrap with the alloys that are coming out? We get mixed smells, and do you guys do anything on the front end for design?
That is a very good question. Think of what we recycle. What is it? It's this chair here. It's a car. It's a truck body. What is a truck body? It's a high strength steel. Yes, with some alloys, but the quality is much, much higher for as what we need for the standard sheet pile production. So actually we would have, or we sometimes have more the problem that the steel is too good. Because the quality is over the years growing, because much more high strength steels are being thrown away. Cranes, that's immediately 100 tons of very, very fine steel. So what we do in the mill is we make a direct analysis of what we have in the big pot. And based on that, we know what we have to put in to get the right quality out of it. So that is part of our quality insurance process. But actually the problem we have is that the steel is getting better.
Other questions, where does the green energy coming from in that world? Have you so much wind turbines there?
No, but we have a big cable going to the North Sea. Holland. Yeah, it's we take it from suppliers from Holland, from Belgium, from big water power stations all around Europe. Very important, it's certified, that it's not just the marketing blah blah. No, we really buy the energy at someone who is producing it from renewable sources. So that's very important. It's not just we say we do it. No, we really also get a different invoice for it because we source it on a different electrical supply. That's for sure. But we also have Cattenom 20 kilometers away, which is one of the biggest, you know it, which is one of the biggest atomic power stations in the world. Yeah.
All right. Well, thank you very much, Ernst.
Okay.
Any
more questions?
Well, good afternoon to you all. My name is Ruben. I'm a project manager with the Waal Solid Foundations. And we're big in Belgium. Well, Belgium itself is not too big, so let's keep it to a small to mid-sized piling contractor. In the next few minutes, I'm going to tell you how we deal with the sustainability subject. Because there's a day with every company when you first hear about sustainability in doing business. And the common first reaction is like, what are you talking about, man? I don't have time for that. I must build a business here. I must maintain my business. And I think that's rather a fair reaction. I'm even convinced that it's a reaction that roots in the same thinking pattern as all sustainability questions asked. How do we sustain something? And as the United Nations launch their SDGs in the question, how do we sustain humanity? How do we sustain society? Any business should, or any company should ask itself the question, how do we sustain our business for the long term? And the first goal of any business should be making money. Profit. Profit should be the goal. But far too long after the beginning of the Industrial Revolution, profit was the only goal. And nowadays, we know that that wasn't the ideal point of view. Past generations learned it the hard way, but they've learned that a company consists of its people. And as profit must be made, it cannot and it may not happen on the expense of its people. A business, to be successful, should find a nice balance between its profit and its people. Now, last decades, well, in fact, that became anchored in legislation, and we all think about it, act on it, react on it by means of health and safety management systems and so on. The last decades, we learned another thing. It's that a company is part of the world around it. And the world is getting smaller. It's not endless anymore. And a company is not only part of it, it depends on it also. For example, for its resources. And nothing is unlimited. Only since a few weeks again, we learned the hard way how dependent we are for resources from the world around ourselves. Seems to be the only lessons humankind wants to learn are the hard ones. But we discovered that to build a successful business for the long term, you need to find the right balance between profit, between your people, and between the world around you. And that's what sustainability is all about. Now, nice philosophy. But the question is, how do we incorporate that sustainable balance or that balance of sustainability into our daily work? And it seems a hard question, but we started to look from the inside. Who are we as a company? What do we do and why do we do it? What is our motivation? Why do we work? What are our drivers? It came to be that our main driver is the client. We have the saying in Belgium, the client is the king. Well, the king demands and we act upon it. Now, most of the time we are subcontracting for bigger building groups, main contractors. But if the project is big enough, it happens that we work directly for the main client also. And they have their own drivers, like the main private client wants to build something. To build it, he must get a permit. To get a permit, he must make commitments to legislation, and he must make commitments to the world around the project, being environment and the people that live there. Now, to fulfill these commitments, he needs the contractors to cooperate. And that's how it comes back to us. That's since a couple of years now, more and more. We're getting asked about our emissions, scope 1, 2, and 3. But we're also getting asked about our actions. What will you do to lower your emissions for this project? How will you adapt your works to the environment? And it becomes more often that we need to give this information to the client. Now, for scope 1 and 2 emissions, being the energy you have under your control, being the energy used in your offices and on job sites, it's rather easy. You ask your accountant, how many energy did we buy? You transfer it to a CO2 equivalent. And voila, after 3 years, you have a nice graph to send to your client with some more information. You can even see the 2020 COVID dip right here because it's our absolute figures. But this becomes more interesting when you set out your scope 1 and 2 emissions to your yearly turnover. From that point, you have a benchmark. You can monitor what you're doing, and you set goals. You can set goals if you want for improvement. Now, how you improve these figures, that's up to you. You can buy green electricity contracts. You can put sun power on the roof. You can use biofuels. If I can make a recommendation here, the new EFFC carbon reduction guide can give you some good advice on it, and it's mentioning some quick wins how to improve. So that's rather easy. It becomes more complex when you're asked after your scope 3 emissions. It's to say on a company level, because we have around 600 projects a year as a contractor. Some of them are big, we're piling for months. Other ones, and most of them are rather small, piling for 3 days, 2 days, even 1 day. So it's difficult to monitor because every project has its suppliers and so on, based on the project itself. But we can monitor it on a project level. And that's what we are trying to do now. We monitor our scope 3 emissions for projects from a certain turnover. Now this is a visualization I kind of stole from Keller, but thank you, Keller. But it's also in the carbon reduction guide. So that's why I use it. It's a nice visualization of the ratio of emissions in a foundation project. And as you can see, scope 1 and 2 together are very small against, in comparison to the part of materials used. And in fact, that gives us an opportunity. If you want to reduce your emissions, you have the biggest wins to make in reducing your materials. But it also gives you the opportunity from being reactive on your client demand to being proactive with proposals to your client. You get a design and we are the contractor. We know what's possible with our kind of machines in that kind of soil we have on the job site. Add a little bit of geotechnical engineering, a bit of engineering judgment, and you can make or you can optimize designs and get back with that proposal to your client. Not only will he most often see the economic relevance of it, but as a blueberry on the cake, you can mark the emissions that you're saving. And it might just win you the contract. To give you another recommendation I can make here for making calculations of your footprint, the EFFC DFI carbon calculator is a great tool. Also to compare different kinds of foundation types and different kinds of projects. That's what we did, for example, with a design we got in board piles. We needed to make board piles, but we took the soil investigation and we said, our machines can make soil displacement piles to the right depth here. So we optimized design to another pile type, we sent it to the client. We were able to maximize our profit while saving over 500 tons of CO2 equivalent. And it's rather easy and handy to calculate it with the carbon calculator at hand. Another thing we've grown to be more proactive in, rather than, well, it started with being active to client demand. That is, in our ways, we are adapting our works to the environment. So now, the more and more from our own initiative, we are communicating to the client on logistics, how we're gonna get in the big machines, how we're gonna get them out, and how we're gonna do our logistics in the surroundings of the job site. Working hours, noise control, vibration control, dust control, all those things, waste control. And we're even advising our clients to communicate and talk to the neighborhood about our works. So that's a little bit our client as a main driver. Another one of our drivers, of course, is changing legislation, mainly by the EU, but we have to be on top of the game. We have to be the sharpest knife in the kitchen, so we follow it up actively. It goes about machinery, what's possible and what not. But now, for example, we hear about the EU Corporate Sustainability Reporting Directive, which will make us have to communicate or have to send in our scope 1 and 2 emissions, but also the challenges climate change is meaning for our kind of business. And then another, like a mother driving her child to grow up and to prepare for the future, we have our mother company, which is a big Belgian building group. And of course, this group, it has its commitments, its accreditations, and an image to build, to maintain. It even has this part in participating in a sustainability management system called the CO2 performance ladder. It's on a certain level, not to get too detailed in it, but they're asking us, of course, to fit in and to dedicate to their strategy, because they have a sustainability manager dedicated full time. And of course, together with the management, he makes up a sustainability action plan, a strategy with ambitions and on certain teams. He even compares it to the SDGs, the Sustainable Development Goals. And he also sets some key point indicators, which you can then measure yourself to. And then, of course, they're asking us, how can you fit in the strategy? How can your work follow the group strategy? So it forces us to think about it and to think about the future. Now, last but not least, one of our biggest drivers is our workforce, because how difficult it is to find good people and to keep them. It's not easy, not in Belgium. Though. So we used to be a small family-based company with a family-based culture. And as we grow bigger, we want to maintain that, but that's not always easy. So we have to actively make commitments and focus on these commitments. Commitments like informing on safety and well-being, good training programs, also participation of our workforce, very important. Listen to their ideas. They have good ideas about safety and sustainability. We want to focus on permanent teams because it's good for the team, and keeping these teams with their machines is good for safety, but also for the team on its whole. We're optimizing work job site transportation, and we want to cherish the family-based company culture. So that's in short what we are doing. And from being a deep foundation contractor, we are now the deep foundation contractor that sort of knows and monitor its emissions and set goals. We are sharing information also on our actions with our clients and help them to reach their goals. We are adapting to legislation to reach environmental goals. We are very open for improvement and implementation of a sustainability management system, which will be the near future for us. And we try to invest a lot in a durable workforce to create one company team. And if you ask us these days about sustainability again, we can answer you that we discovered that by sustaining a better business, we're actually founding a better world around us. Thank you.
Talk. It was very good. It's also always embarrassing for a native English speaker when a non-native English speaker uses an expression like the sharpest knife in the kitchen, which I've actually never ever heard before. So, but anyway, questions? You floored them, Ruben.
No questions.
They're in shock.
you very much for your. Very much for this interesting talk. You mentioned the CO2 performance ladder as one of the instruments that you're applying. I was wondering whether your clients are using other instruments to determine the sustainability impact of your work. Could you comment on that?
Yeah, you have different kind of tools and the management systems. One also well known, also coming from the Netherlands, is Graham, for example. Okay. But there's a lot of those tools coming from the Netherlands, like the CO2 performance ladder, also coming from them, and it just started to grow as a management tool in Belgium. So there are a lot of tools, but the biggest weight now is shifting towards the CO2 performance ladder, which is in fact a nice tool because it makes you think on your emissions, how to reduce them, but also on how to communicate about them. And then you have different levels of the ladder. Of course, the higher you get, the more specific you have to be.
We have time for one more question. Justino, sir.
Thank you. When we saw the pictures of you, you're still from Keller, I think what you saw is the impact of materials, mostly concrete and cement. And I was wondering, do you feel like in Belgium, is there you see a change in the industry or coming from the materials so that you can act? Because when we look at the result, the part of material is 80% of your. So that means that the margin to reduce the CO2 from once you get the reduction on all that is scope 1 and 2, the scope 3 is a large part. And how do you feel? I'm just interested to see how it's taken in Belgium.
Oh, yeah, the best way to downsize emissions is downsizing on materials. So if you can change the design, you have the biggest wins. But next to that, there is investigation on how can we replace those, let's say, polluting elements of concrete and steel, because the production emissions of cement and steel are that big that everybody is looking for replacements, but it's not that easy. The BBRI in Belgium has launched a couple of years ago, a search for, it was called circular concrete, is to how can we lower the footprint of concrete. They haven't built a nice report, and there are a lot of companies that are working on it also to replace cement, for example, but just getting off. It's not there yet. They're starting, and it will come, but it's not ready for use in a deep foundation element yet. So it's future, but they're working on it theoretically, and companies are also trying to manufacture some replacements. That is.
Thank you, Ruben.
Chris, thanks very much for the invitation. It's a real pleasure to be here, and just compliments to all the other speakers. Really enjoyed the sessions this morning and this afternoon. This is very much a perspective similar to what Alice had this morning from a consultant's point of view. I've split it into two. We'll have the sort of corporate overview of AECOM and how we view sustainability and what we're doing, what that challenge brings for us as a company. And then it's a more personal view as to what I, as a geotechnical engineer and leading a team of ground engineers in the UK, what our focus is, how we believe we can contribute to the subject. So AECOM by numbers, many of you won't be familiar with AECOM. It's an American-owned company. We've got somewhere just under 50,000 people around the world. We turn over close to 15 billion is what we'll close out this year on. So we're a very, very large multidisciplinary consultants. Now, where did our sustainability journey start? And it's the same as we've seen with a lot of other people today, with the UN Sustainable Development Goals. That's really what set the benchmark for people to drive and attain goals that were also adopted by governments all around the world. So this was back in 2015. That's developed. Last year, in fact, this time last year, we produced what's called our Sustainable Legacies Program. And this covers everything from sustainability, really encompassed in the whole ESG topic though. And this details internally, and also if you're interested on the website, where as a company we feel we have to be, where we want to be, what our realistic targets are. So there's 4 key pillars to that sustainability program. One is embedding sustainable development and resilience across everything that we do, all the work that we produce. We also have to make sure we're improving social outcomes, not only for our employees, but for the communities that we're operating within. And of course, we've got net zero ambitions for our company. And we also want to try and include all those in enhancing governance, not only of our own organization, but also of the organizations that we work with and work for. So really, I'm just going to focus in on 2 of those, embedded sustainable development in everything we do. And that will hopefully lead to a reduction in net zero carbon emissions. Sustainable development, one of the key drivers that we're working on this has been the development of a cloud-based software package called ScopeX. This is developed to allow whole life cycle assessments to be done on large projects, mega projects, to help manage the reduction of embedded carbon from a design point of view. This has just been rolled out in the last 12 months. It's a fascinating tool. I can't claim to be an expert on it, but if it helps us in any way to get those goals, then it's a very important tool in our toolbox. Achieving net zero, our ambition stated a few years ago was to be operationally net zero by 2021. Of course, we achieved that mainly on the back of COVID. We had people not traveling, we had offices not using any power. It was quite an easy target in that sense. But we've built on that. During the pandemic, we've reduced the sizes of our offices. We've moved to more energy efficient buildings, and we've adopted hybrid working in one form or other around the world for our staff. One of the key things we've done is to cut down on business travel. And this was a huge revelation to many people, was how much carbon was involved in traveling. And I think you'll all agree that we've learned how to use Teams and Zoom and all these communication methods, which makes it so much easier for us to actually communicate without necessarily having to go and drive to the other end of the country or fly to a different continent to do that. So we've achieved, Alice, and your eyeball diagram, I loved that. We've achieved that tiny little nugget of operational scope 1, scope 2, but we've still got the rest to go at, and to really try and get the supply chain carbon under control is a much bigger task, and that's something we've of course got targeted for 2030. Tick. Also, somebody rang me just before I finished this presentation and said, make sure you mention that AECOM's the first multinational organization in the States that's actually going to have its targets essentially audited or verified by the SBTI. So there you go. I've told you. Corporate message over. Where's the corporate blah blah? Where was that? So how are we going to embed sustainability in everything we do? I'm a geotechnical engineer by training and by trade, and I'm well aware of the sheer volume of concrete that we put into the ground. Ruben, I loved your presentation. I could have just had your presentation up and gone home, I think, because everything that you are espousing is how I'm thinking. There's a few fundamental truths that we need to admit to. There's definitely a correlation between depth of foundations, risk, cost. Typically, we know that between 20 and 25% of costs are all in the foundations. Deep foundations, substructures, basements, retaining walls, whatever you want to call them. So the embodied carbon within all those structures equates to the volume of concrete, as we saw in Ruben's Keller diagram. The sheer size of the impact we can make just by reducing volume of concrete and steel is huge. And that's where I'm thinking. I'm not worried about everybody in my team getting an electric car or traveling to work by donkey or something. I think this is where we can make the most fundamental impact on what we do day in, day out as engineers. So volume of concrete, this comes back to the old question of, well, you know, how is it over-designed? Are we being too conservative in our design? And that swings back to the other side of the argument is, well, do we have enough information? Do we have enough GI data to enable us to do a design that isn't overly conservative? And 99% of the time, we as ground engineers, we're going to say, no, we don't. So design conservatism comes from unknowns. But ground investigation informs all these unknowns. It lowers the design risk, makes us have more optimized structures, as Ruben was promoting. Therefore, we lower the volume of concrete, we lower the embodied CO2 massively. So this, I think, is really, from a personal point of view, where we have to be. And I think I've got a couple of minutes just to show you this example from a colleague in Australia. This was a client's baseline design of a bridge. It's a project that's currently being built in Melbourne, in Australia. This was the baseline design, 5 piers supporting a bridge for a railway line. There are board piles supporting the piers. There's precast concrete elements there for retaining walls. I'm sorry about the graphics, but I had to steal them off a presentation. And this was the rationalized design. That particular project has a very focused sustainability management protocol attached to it. And they actually review every structure on the job to see if they can make it more cost effective for the client. But the client has challenged them to have at least a 20% carbon reduction from the baseline. And this was what they came up with. They spent something like, what's that in euros? About 10,000 euros in additional GI, which meant they could rationalize the foundation design. They could have reduced the number of piers because they had higher bearing capacity, but lower diameter piles. Kimberly, you can tell us how they managed that. And the retaining structures were replaced from being precast units, which had backfill behind them, into, again, board pile walls. And this is the type of thing that we need to embed into or embrace. And it is client driven. I take the point from the earlier presentation that a lot of this will only come from clients pushing us to do this. What is the client's appetite for sustainability and reduction in CO2? Because it won't ever get embedded into sort of legal codes for many decades to come. You can see here just some of the numbers that we're looking at just by simple changes We've got 109 tons of CO2 saved, 500 tons saved, 295 tons saved. And at the end of the day, they ended up with a structure, so it cost less. It was safer because there was better lines of sight and visibility for the pedestrians. There was less concrete volume in there, and it was reduced sustainability. So I think this is a fantastic example of where we as engineers, as ground engineers or geotechnical engineers, make a huge, huge impact. But it has to be hand in hand with experts from the ground engineering, piling, contracting world, who are as we've seen, at the forefront of what's possible. So I will finish there.
I know I'm not presenting, but I think whilst I accept the 80% is the big number to go for, but I think we mustn't lose sight of the fact that, I just checked on the web, there are 1.5 billion cars in the world. They all saved 100 kilos a year. That's 150 million tons saved. Yeah? So that by the power of large numbers with small movements, it can have a very big effect. So yeah, we're not going to solve geotechnics looking at cars, I agree, but as a planet and people on the planet, it goes a long way to help. So I'll shut up now. Questions for Neil? So, put your hand up first.
So thank you very much for your interesting presentation. I have actually two quick questions. The first one is, don't you think there is a paradox when you say that by increasing the amount of the ground investigation, you might reduce the CO2 due to the foundation because you know better the ground, but at the end of the day, it's not really the truth because you still have certain uncertainty, during the design.
Yeah.
Second question is from the engineering point of view. Have you ever evaluated the impact of the different materials substituting the cement, such as metal cowling? Because at the end of the day, we know that, for instance, metal cowling, which is one of the heats in these days, still is not really reliable because of cracking, above all when you have changing water conditions, or when it's not really under humidity. So this is my questions.
Great. Can I take your second question first? I don't really personally, this isn't an AECOM statement, I personally don't have much time for substituting cement or with low carbon alternatives. I can achieve much greater savings by reducing the volume of concrete rather than paying more to somebody who comes along with a bag of something that doesn't. So yeah, I personally, I don't believe you have to pay more for sustainability, bottom line. Your first question, I don't think it's a paradox. I think it's well proven that the more GI you do, the less conservative your design is. And there was a very good paper published 96 or something, which I'm still trying to find, that shows this. But if you think about the sheer numbers, you think of what's the average cost of a multi-story building? Let's say it's 20 million euros. 20% of your cost of that is in the ground. Yeah. So if you can sweeten your ground engineering by 2%, work through the percentages, you're going to save hundreds of thousands of euros, if not millions. What would that extra borehole have cost you on the project? Well, 2 boreholes. It often comes down to that 20,000 euros difference in GI, and all these other benefits come out of it. And it's the age-old problem we've had as ground engineers is trying to convince clients to spend money up front with the GI. And that's where the expression "you always pay for the GI" comes from. Because if you don't pay for it at the front end of the job, you'll pay for it later on from things that go wrong or unknowns. So that was a bit cynical, wasn't it, both those answers? I'm sorry.
What other industry designs with a factor of safety of 3?
I rest my case.
Talking of factors of safety and also talking of information into power in reducing conservatism in design, could you talk a bit about pile load testing as well and what that does to the size of piles?
Gosh, how long have we got? I might have to bring in Kimberly on this one. Yes, I mean we have our performance criteria, don't we? And this I would sort of loop this back to the whole GI. If we have more information on GI and we can be when we're doing pile load testing, we of course always be more conservative in our design if we know they're going to be tested. That's with my Keller hat on because I used to be a contractor. Maybe not. Yes. Yes, testing to failure would be wonderful. Yes, if we could on everything. You're right. That's where we. That's a very good point. But I think, yeah, generally, if people are doing pile load tests just to look at safe working loads, or like soil nail pullouts or something like that, there tends to be a lot of, you know, we'll make sure this works, you know, going in, even beyond what's specified. So, you know, testing has its place. But you've sown a kernel of interest there in my mind with your question, actually, about testing to failure.
Yeah, one comment. Excellent presentation, thank you. The missing link for me is to work on the norms, the oral codes, and whatever the norms worldwide.
Yeah.
I think so. There are a lot of buffer in the norms. To say it, if you didn't have the information of the soil condition or something else, of loads of buildings, also, then you have a buffer in the as a risk factor or something in norms. Yeah. And the other points in norms is for the concrete norm, AU 1045, it is not allowed to bring in recycling material, or you can test it in 96 days.
Yeah.
I think so. There is a potential that we can handle, but we need 8 years to change in the norm something. Yeah?
Yes.
So the movements are to not far enough.
Yeah, and you're right. I mean, norms they are conservative by nature, because not only because they're produced by a committee, but because they're trying to not, you know, get themselves into trouble ultimately. But they're a great guide. They're a great guide. But at the end of the day, if you're looking at BS 8006 or something in the UK, it's a code of practice. You can go beyond that. You don't have to rigidly stick with that if you can justify going there. I'm thinking of your Arab colleague, Colin, who's not here, I don't think, he's next door, who has had an article in Ground Engineering recently saying beyond the bounds of empiricism lies innovation, which I think is a fantastic point. And a lot of people will rigidly stick to the guidance and the codes without thinking, well, hold on, what if we did this? Surely we'd still have the same, you know, intention. So I think, yeah, there is conservatism in guides, and we as engineers have to be brave enough to you know, apply them appropriately.
Yeah, or make it realistic.
Yes.
Yeah.
Or test things to failure, and then say, well, actually, we found out that is too conservative.
Yeah. And the next comment is for Chris. Yeah? There's questions. We had checked what happens in our industry and what happens with the cars. If you, a question now, yeah, in CO2 in 1 meter concrete pipe with a diameter from 88 centimeters, you can move 1,600 kilometers. That is to the Moscow city place from Berlin, or only one way. That is for 1 meter pipe. Unbelievable. But it is true.
Do you want to drive to Moscow though?
Yeah, it is. No, nobody wants to drive. But it shows how big is our potential. Yeah, we are happy to produce 200 pilots, 200 linear meters per day, and then we talk with the foreman, you are not quick enough. Yeah? But the potential over the metro is giant.
Yes, it's huge.
It's only for Chris. I sent you the email, just the calculation.
I think the good news is, as far as your norms and standards are concerned, is that I know that the European Commission has started to say that the SEN process is a dinosaur. It takes 15 years from when they first start to coming to their end, and they now understand that they've got to streamline that somehow. I don't know quite how, to bring in innovation and allow what we're trying to do as far as carbon and CO2. So that's positive.
this. They know the problem now. They haven't solved it, but so one last question, if anybody has one. Okay.
Yeah, and going back to the first question, because I'm a material guy. Is there a comparison between if we have worked on the material to reduce CO2 in comparison to reduce the design?
Yeah, absolutely. I mean, I was fascinated by this Mr. Steel Pile presenter, the work that ArcelorMittal are doing on reducing the carbon of steel. I mean, that's great.
No, I mean,
well, with concrete, yes, but as long as it doesn't cost more. Yeah, if you're going to bring along a product that costs more, why would I use that and not just sharpen up my design? That's what I can't. I'm talking about low carbon cement. Yeah, I won't ask the client to pay a premium for low carbon cement when I'm responsible for driving 5 million cars to Moscow by designing my basement. I'm sorry, I won't do it.
It's different perspectives.
Yeah, it is. It is completely. You're right.
Why not do both?
Yeah.
Let's do both.
If we could do both and it didn't cost more, I'd be up for that. Yeah.
I think that you cannot ignore what the cost of CO2 is.
But isn't it a bit like buying a gin and slimline tonic and being charged more for the slimline tonic? You know, it's something you're trying to make a better. Maybe the slimline tonic's a bad example. Yeah, but you know, you're paying. Somebody says, yes, I've got something that's got less of that in, but it's going to cost you more. I'm a bit cynical about that.
Who's going to give a response here?
I was going to say, obviously, we've got a presentation tomorrow on the carbon reduction guide, but you can think there's always a hierarchy. I think Alice kicked us off nicely with this talk about alternative ways to fill the need and that build nothing type argument. Then you can look to, so that's the eliminate, and you can look to reduce, which is all design optimization, ground or biotesting, everything else. Then you can look at all the innovative substitution type things, you know, that then optimize design with lower carbon materials, and then finally with any residual at the end. So it's that hierarchy where first of all you've got to look at bringing your biodiversity down, reduce the volumes of materials. Before that, you've got to look at, and you even look at ground group. So
that can be part of your optimization process. It doesn't have to be looking at materials. Yeah.
So you look at this first, then you look at
just a very absolutely last, because we need to move on.
Just building on what you all said, I completely understand what's said, but I think we also need to realise that even if there are products that do cost more, we also need to think about this going to be credits associated with projects. So yes, the actual upfront cost might be potentially more than these in terms of the actual saving.
Oh my gosh, I don't know. I don't know.
I know, and that's with my geotechnical hat on. In the big picture, it's important.
Okay, many thanks, Neil. That was good.
Hi. My name is Jan. I work for Oslo in Norway. Actually, I work in Sweden and Denmark too. Our newest purchase in Sweden, our electrical piling rig, which we got in November last year. But I just wanted to start a bit with what we do in Oslo, just very quickly. Basically, 3 segments: construction, pipe technologies, and ground engineering. We then take a look at the ground engineering departments. We basically work in Northern Europe, Norway, Sweden, Denmark, Poland, Czechoslovakia, Germany, and the UK. And work with different kinds of ground engineering. onwards. That's just very quickly. Then a bit about how we work with sustainability. We have an also so-called Eco Center, which on group level works with sustainability. Then we have in the different segments, we have working with different committees. But I guess
he's wandering away from the computer, so we need to change the camera a little bit.
Right, sorry. Just I can hear myself over
I'll do it. I'll get it.
Yeah. More practical, how that looks is we are, of course, like most others, we try to establish a baseline and monitor our emissions. We offer emission-reduced alternatives to some clients. I'm responsible for all the office in Norway, for example, and until now, to date, I have offered every project in Norway this year. I have offered with an alternative with lower CO2 in the alternative, and yeah, just to spare some time, I will not go through all the small stuff we work on, but some a bit to maybe a little bit more interesting stuff. We are working on a file system called it's produced by Ceecom, which is part of Oslo and Keller, which will be basically a precast concrete pile, which can be drilled down for which then will have a lower CO2 impact because it can take more capacity than the normal concrete piles. The first tests have shown that we can take almost double the capacity of a different pile with the same amount of concrete. Also, we oh, sorry, just a little video there, just to show you how that can look. Then we also work with energy piles for heating and cooling of buildings. Also, maybe fitting this topic. But what I wanted to talk about was, of course, the electrical piling rig. Produced by IJnsen, and if you get 100 euros for wearing that hat, I should get maybe 50 to have this presentation, because it's basically a commercial for IJnsen. We got this rig to Sweden last year in November, I think. I know we have lots of pretty pictures here. We have a 100% battery powered rig. There's no cable on the rig when we are driving it. Of course, it's as the colleague from Bauer spoke about. We have still the winches and all the gears not electrical yet, but I've heard IJnsen maybe will talk about that. Then we got two batteries on the rig. Instead of the counterweight in the back, we have the battery attached, and we can just switch out the batteries for fast charging. But actually, we have worked through a whole day without changing the battery, just plugging it in when we're taking a break. For longer days, the two batteries are really necessary, but not for normal days. But then we have also the same power as a standard PMX 22. which is a pretty normal sized piling rig in Sweden. We have an electric motor of 266 kilowatts, I guess that should be. 2 batteries with around 400 kilowatts, and my colleague from the machine department told me that we have 30% more effectivity on the electric driveline, and that was important, but don't ask me what that means. Otherwise, as I said, the same construction as the PMX-22. It has a bit more power, but less consumption. If I don't think there's anybody in here that claims that climate change is not happening and CO2 is nothing to worry about. But if you are, I can tell you that this rig is very popular in our workforce, mostly because of the noise and the better air quality. We have the rig driver and the banksman, they can communicate very easily while driving, basically, not while driving piles, that still makes a little bit of sound. But otherwise it's very easy to communicate through both from inside the rig to the guy outside. On top of that, we save 14,000 liters of diesel a year, and and it still works on a standard 63 amperes for charging, which is very nice. So our experience after 6 months of use, we have basically no mechanical problems. I guess we had a day of standstill. But we had no time lost for oil change or something like that. The rig has been driving all the time. We have the same productivity as a standard diesel-driven rig. And so far, I haven't had any issues with the electricity on site. I heard that question before. Can you get enough electricity with only 63 amperes needed? That was no problem at all. And also in the beginning, we only had one battery and had to drive through parts of the winter with only one battery, and we didn't even have a problem with keeping it running all day with only the one battery in a pretty cold Swedish winter we had last year. Still, of course, there are some challenges we have to look at. The emissions, of course, are depending on the energy mix, which in Sweden is very, very lucky for this kind of electric rig with lots of hydropower. And the drilling rig is just slightly heavier, but that doesn't really mean anything for us for transportation or the working platform. But then the purchase price, of course, is a bit higher. But I think I've seen colleagues from IJnsen standing down there and maybe having some time to tell you more about the price of the rig. And then just to try not to make it too much of a commercial, I wanted to show some alternatives of electrical drilling rigs, and I found some different machines on or pictures of machines online. Liebherr has had LB16 in drilling in Norway with the hammer, I think, which in itself for the generation of pressured air. Then we, of course, heard about the Bauer electric BG33. And also we have heard that there's a Liebherr piling rig coming out, which I haven't seen yet, but I guess should work just as fine. That's basically it. And if you have any questions.
Yep. Okay. I have yours, and you're all set. So if you don't want to go,
no, I just wanted to check.
Yeah. Great, we will be there.
Fantastic. So 7:30 tomorrow. Great. Then.
Did you like that ad for your competitor, Franz? Did you like that ad for your competitor? Did you enjoy the ad for your competitor?
I guess we would get 2 more batteries. Or maybe just 1 extra.
There you go. That works.
Well, no, we just change it. We take it off the rig. Then the battery basically works as a counterweight. So we take the battery off, put a new one in, just like a normal hand drill. Like a power tool. Yeah, it works very good. It's very, as I said, very popular with the workforce.
You know that the battery reduce the capacity over 40% in the wintertime. In the gas battery is also need 63 amperes per battery, so per charger. If you have 2 rigs, yeah, you need 2 loading points, yeah, with 125 ampere. That is the challenge. That is a big cable. Yeah. There is no normally around the site, no infrastructure. But at that time, the building has this later, but not for the foundation time. So we are limited at the moment, but it's excellent coming days. 1 comment to the LB16. Yeah, it is a toy. We had workers in Copenhagen, yeah, in his home country. It's not really a strong rig, yeah.
What is it, 16-ton meters?
Yeah.
But one thing that I wondered, and I'm not sure you can answer this, Jan, with respect, but is it possible to run a rig off part battery and part mains? I don't know if you can combine the 2.
There have been discussions about that with a different manufacturer.
That's maybe an option on the bigger stuff initially. Anyway, that leads us nicely on to, thanks very much, Jan, for that.
Right, thanks for bearing with us. Yeah, my name's Stuart Norman, and I'm probably going to bring quite a few themes together right at the end, so well done for putting me on at the end, Chris. A little bit about ourselves, Keltbray, quite similar in terms of De Waal, Germany piling contractors, part of a larger group, turnover around about 550 million a year. Piling wise is about a 10th of that. That's kind of who we are, Keltbray, in terms of our mission statement to redefine the way sustainable development is delivered. And as per a lot of the presentations today, we work and operate in accordance with the UN Sustainable Development Goals. So I won't go through those with you again. What we started doing, again, quite a bit of a theme here today. Yes, we report our Scope 1 and our Scope 2 emissions annually. We've now started to look at our Scope 3 emissions in terms of 2021. We looked at the embodied carbon placed in the foundation concrete that we used. It was around about 13,000 tonnes, and more accurate calculations are being done on that to nail that down into different techniques. In terms of the earth-friendly concrete that I'm kind of here today to give you a little bit of an overview on, We placed 900 meter cube, and that's the first time, certainly in the UK, perhaps even in the world, that we utilise that earth-friendly concrete in permanent works foundation piles. And thereby doing that, we saved 240 tonnes of embodied carbon in the foundations. So the pictures there give an indication of the level of rigour in terms of the testing. Yes, that's the on-site testing, but before that, there was an awful lot of off-site testing. We had a very proactive client, British Land, for a project down at Canada Water. They said to us, we've heard about this earth-friendly concrete stuff. We want you to use it. To give you an idea, earth-friendly concrete is a zero ordinary Portland cement-based concrete, so it's an alkali-activated concrete mixture. So I think there's been some presentations here today talking about the heavy use of OPC. There's zero OPC. It's around about 340 kgs per meter cube of secondary cementitious material, comprising GGBS and PFA with a strong alkali activator. So normally when you get down to a CEM3C type mix, the 5 to 10% of OPC is acting as your activator. We've got rid of that activator and replaced it with a strong alkali instead. So we use that for CFA piles. There's about 240 piles, 250 piles, 600 millimeters and 750 millimeter diameter CFA piles, to around about 25 meters deep. We've done a lot of testing and trials to lead up to that point. A lot of lessons learned along the way, primarily that OPC doesn't mix well with the Wagner EFFC material. When we were changing from one mode to another in the back of the CFA rig, those two concretes mixed in the lines and everything got blocked within about 10 minutes. So very, very highly reactive in terms of setting times, etc., especially when mixed with OPC. So I'll talk a little bit more about that in a second. So our strategy for working sustainably, yes, to qualify and quantify our Scope 3 emissions. I'm working on behalf of the FPS to set industry benchmarks across the various techniques. So I was very interested to see Kimberly's presentation at the start, looking at the different techniques and where we are. There's been a recent guide published by the ICE, so the Low Carbon Concrete Group, really starting to look at the different concretes that we use as an industry and look at the embodied CO2 within each of those concrete mixes. Where we want to get to is we want to set industry benchmarks year on year to try and improve from that and to benchmark per meter cube and per million pounds of turnover, which I think Ruben said in terms of earlier, in terms of ways that we can improve. And ultimately, we want to provide our clients with the information to place orders based on price, program, or embodied carbon. So we give them the choice. We are driven to reduce material quantities by design, and one of our major innovations that I'll show you in a minute does exactly that. So again, a lot of talk earlier was about, yes, we'd like to reduce the volume of material by design, not too fussed about reducing quantity of embodied carbon within the materials. Well, we'd like to do both. We work collaboratively across the industry, and we believe that early contractor involvement is now more important than ever. Quite often we get involved at kind of stage 3. I think that's too late. We need to be much more involved, almost at concept stage, as a contractor-led organisation to really bring some significant changes. Again, a theme that was discussed earlier on today. We want to continue to eliminate waste and embrace modern methods of construction, so design for manufacturing assembly, which I'll come to in a second in regard to our hyperpile product. So the Canada Water project, based in East London, this is where we utilised earth-friendly concrete. We had about 8 to 10 weeks worth of lead-in for this with a very driven client. And we said, why not, rather than why should we? So we took a step back and we thought, well, why not piles? If we're going to use this new material, the piles themselves are generally subjected to compression loading, not bending. They're actually cured in an ideal environment in the ground. It's generally around about 15 degrees C. They're allowed to gain their strength slowly because we don't just plonk the building on day 2. The piles in the ground are not actually subject to surface carbonation. So you look at durability limit state and say, well, fail because of durability limit state. Well,
we're not bothered about surface carbonation because the things are in the ground. We also don't need to design them for fire because the ground generally doesn't catch fire. And on that particular site, chloride attack wasn't an issue. So we're only really talking about sulfate attack. And as luck would have it, because of the high GGBS quantities associated with the mix design itself, that actually provides enhanced protection over standard OPC-based mixes against sulfate attacks. So to coin a better phrase in terms of ticks, we were tick, tick, tick all the way down. And as a foundation contractor, we were generally a performance-based specification item. So we come back to design, we design pretty much all of our piles. We get to specify what goes in them, how long they are. We get to shorten them up by a meter if we choose to in terms of a risk-based design. So proposal and reality. So what we wanted to do was utilize earth-friendly concrete for all piles, caps, and basement slab. Unfortunately, timescales didn't permit that in terms of the contract and the project duration. So we managed to get just enough testing to do and to be done to incorporate the earth-friendly concrete into the piles. A structural mix, C3240, and we were generally getting around about 25 newtons of about 7 days. So a typical standard equivalent to an OPC-based mix. We didn't have enough testing data on the C4050. We went out to an industry expert, a guy called Dr. Peter Robury, to literally tear the information that was provided to us by Wagner's to shreds and say, look, we want to use it. Give us the lowdown on why we can't use it, rather than anything else. And he came back and said, yeah, for the application you want to use it for, we will support that, and he will support that as an independent expert. And this is all in accordance with PAS 8820, which there's a window of opportunity within BSEN 206 and Eurocode 2. So there's no excuse for us not to be doing it apart from availability, and that's of the material itself, and that's a whole different discussion. So we do have some surface carbonation testing ongoing anyway for use of the earth-friendly concrete materials above ground, and we have got a close working relationship with Wagner's, and they have a European technical assessment document underway, and that's due to be released any day now. The other aspect of what we've been doing essentially is our hyperpile. So HYPER is an acronym, generally stands for what it says on the screen there: hollow, impression enhanced, precast, energy generation and storage pile, and fully reusable. So we spoke a lot about reducing and getting rid of waste through a hollow pile. We also spoke about factors of safety. There's a structural factor of safety, typically a set of 4 associated with piles. So we're trying to limit the wastage there and match the geotechnical capacity to the structural capacity of the pile in a much better way. So that's the reason for the hollow. The impression enhancements, basically we're able to mimic a larger diameter pile by not putting in the volume of material. So we have a special tool, which I've got a picture of in a minute, that goes down, impresses the soil, and comes back again, just kind of like when you're a little kid, put your thumb in a clay pot, you remold the clay. That's exactly what we do with our impression tool. The P is for precast. So we've now fully embraced DFMA within rotary board pile construction. Again, we've built piles about 25 meters deep. Advantage of that is we can incorporate our earth-friendly concrete off-site to get rid of any potential quality issues that may be associated with that. And then the kind of the brainwaves start going overload in terms of what do you use the hollow core for energy storage and generation, and we get around about a 60% enhancement in thermal conductivity, and the pile itself is fully reusable. So we come back to whether we need the pile in the first place. Well, if you can reuse the pile that was there in the first place, then you don't even need to talk about materials or factor of safety or anything else. So that, for the first time, really enables a fully circular economy foundation, with the ability to inspect the pile as it's in the ground and already in operation, and whilst the building's being demolished. So all of those elements in various ways incorporate smart technology. We have 5 patents pending, some of them worldwide. And the summary of the benefits are on the screen there for all to see. currently working through an EPD to back up some of the claims here. But effectively, by reusing the piles once, incorporating the earth-friendly concrete, taking out the material that's not needed, we get to around about a 90% saving in embodied carbon. Up to a 40% increase in skin friction in certain ground conditions, an overall 30 to 70% material volume saving depending on the diameter of the pile itself, a 60% increase in thermal conductivity, and obviously fully reusable. So we could talk about the big numbers all day long, but it's a lot of talking here today around about the indirect consequences of what we do, the number of vehicle movements to site, the noise that we impact on our surroundings, the number of the improved air quality through to fewer vehicle movements, as well as better quality management in terms of our ability now to form these piles at an exact level rather than have any pile breaking down. So yeah. So a little bit about the first project that we've done for High Speed 2 with the Hyperpile, Maria Fidelis, 40 piles, a combination of cast in situ and precast board piles. That's our impression tool on the left-hand side there. Basically mimics, it's a 750 diameter bore, but it mimics a 900 mil diameter pile. Strain gauges and things being installed into the temporary and permanent steel liner for the cast in situ versions going in the ground. And that's the precast version of the Hyperpile, essentially built in sections from the bottom up, and we use pre-stressed strands to pull everything together thereafter, and with a cap piece to form the pile at the correct level. There's the cap piece there. That's the pre-stressing going on. And then once we finished, there's Arslef, little nod to Arslef there, sponsorship, 50 euros for you later on, that'd be amazing. Grouting up the annulus between the precast and the ground. So I've rattled through there quite quickly, just to try and keep you guys on time. But we're very proud to have been nominated with this product for the Earthshot Prize, and yeah, more will come, I'm sure. So thanks for listening.
Sure. What a good idea. Questions?
Is there a question in the chat?
You're all getting thirsty as well. Come on, we must have one question for sure. Alice.
It's great to see innovation in an area where we've been building this same kind of pile in London, particularly for years and years and years. Just a question on the reusable bit. Is that reusable in situ or extractable and reusable somewhere else?
Reusable in situ, Alice, yeah. So the little graphic that I've got that I didn't show you today is we're able to call through the slab at the pile locations, call through the cap, drop a little camera down, inspect the pile with the light, obviously, during its operation. And if we need to, we can then redesign the pile, core through the base, extend for a deeper load, and then cast it again. It might be solid second time around, it might be hollow second time around, depending on the structural load.
Yeah, that's good, because the big barrier to reuse is still
lack of
certainty on the quality of what is in the ground already.
That's right.
Yeah, just to echo what Alice says, that's really cool with the Hyperpile. I've said that many times already. My question was just very quickly in terms of the uptake of it, because it needs above surface infrastructure to use things like the ground source heat pump in there. What kind of use have you got so far? Have you got projects lined up with it?
So we now secured our second, third, fourth, fifth, and sixth projects with HS2. To give you an example, the cost of the installation of those 40 piles was around about £700,000, so quite expensive. It is a highly innovative project. It will be monitored for the next 10 years, but the energy the energy cost or saving that will have over those 10 years is £700,000. We're going to heat and cool the building for 10 years just from the piles alone. So it gives you an idea of we don't have to innovate too much more to make this a real product that will fly off the shelves. We're looking at whole life value, not just what does the pile cost. Yeah, and that's what we've got to get our heads around.
I have two questions, please. So, the first one, if I understand right, so you used a lot of slag, and the OPC was just an activator.
So in the earth-friendly concrete, there's no OPC at all. So the current standards in BSEN or Eurocode 206 allows you to get to a 7.3C mix, which is 95% GGBS and 5% OPC. With the earth-friendly concrete, we've gone a stage further, and we've taken out the OPC and we've replaced it with a strong alkali activator, which sets the concrete off.
And so now it's not the second question. So this the activator, how percent from the OPC was it? Does it do that?
It's we've removed the last 5% of OPC that you're allowed to do under the code.
So you just replaced one.
Yeah.
And the second question, if I'm not mistaken, from our projects in the UK, you have also problem with the slag itself. It's not available that much.
So this again, this is a good question, and you get to understand that probably at that time really that not all slags are the same, because the quality control about where they're manufactured. You know, they come from Brazil, they come from Spain, they come from India, they come from China. Yeah, so there are many different constituents depending on the iron ores that go into produce the slag itself. So we learned the hard way, but some of the EFC itself needs a particular grading of slag in order for it to work. And that's not what we'd normally expect. Normally when you do a normal concrete mix, any GGBS will do, because the OPC itself sets the activation off, because the OPC is a very strong activator.
I don't know if you see it on screen, Stuart, but we have questions online.
Yes. So is the precast version also equipped with strain gauges? Yes, it can be. Yes, it can be. We don't really need to do any integrity testing because all the units are precast, so they all lock together. Like I say, we pre-stress them by jacking them together as well. All versions of Hyperpile equipped with sensors and strain gauges like the cast in situ. There can be, but again, it comes down to confidence. We spoke a lot about confidence in the ground engineering side of it. How much testing do you need to do? Do you need to instrument every single pile, or do you look at 5%, 10%? It's really every project's going to have its own merits.
Thank you. Sorry for interrupting. Very last question to Christoph Justino for today.
Round back, Marcel.
Just two questions to finish. Experience I have with replacement of Portland cement in is the durability is quite low or can be severe. How to control this? This side you made some statements about durability, but in general, how to control it. And the second one is we made this type 20 years ago, also with the purpose of monopiles for earthworm storage. It was not so successful because the concrete is a good isolator. How are you going to do with that?
Good questions. Okay. So the first one, the EFC itself as a binder is a much stronger binder. So it actually gives you a slightly denser and less porous concrete. So in of itself, it's a more durable matrix. Particularly when you're looking in the ground in terms of the sulfate resistance. What do you do when you get to a DC4? You just keep adding more and more GGBS, where actually the earth-friendly concrete is an equivalent to a DC5, which is what you don't currently have. There's a correct statement in terms of concrete is more of an insulator. That's why we build basements out of it, because it keeps the cold out and keeps the warm in. The advantage of the Hyperpile as a precast or under cast in situ is the barrier is now only 200 millimeters thick. So we can actually get the heat to and from the ground much quicker, which is why it's 60% more thermally conductive. The normal pipes that go in solid piles, it's a great big solid mass of concrete, very, very poor conductor of heat. because we've got a water or a thermal grout, which is very highly conductive and good at storing energy. We only have 200 millimeters of structural concrete to get through to get the heat to and from the earth.
Stuart, thank you very much. That was excellent.
Yeah, thank you very much.
So I will leave Patrick to finish off today.
Right, thank you, Chris. Chris told me to keep it short. I already hear gin and tonics, and I'm not going to hold you here for long. First of all, I want one more round of applause for our speakers. Because without them, we wouldn't have anything to discuss. All attendees as well, and for the contributions. My colleague Chris for making this happen together. Back of the room, Gerald Verbeek for helping us putting this together.